Good morning, friends. Welcome back in the revision video of 69. Clear? In this video, we will try to solve few short questions as well as numericals, which will be helpful in future. Clear? In this video, we are going to discuss few short questions that I like to wish. Okay? And first short question is about what is fission, right? In the Zoom lecture also we have seen what is fission, but once again let us take fission. Okay, in fission, what is that? This is heavy nuclei is bombarded by neutron. Heavy nuclei absorb the energy of neutron and becomes this heavy nuclei becomes unstable, right? After becoming unstable, it is divided into two, that is two lighter nuclei. So they are the lighter nuclei. Got it? So this is fission reaction in the form of figure. Simple. When a heavy nuclei is bombarded by neutron, heavy nuclei absorb the energy of neutron and become unstable. Then it may split into two lighter nuclei. This reaction is known as fission reaction. After one fission reaction, we know very well two or more neutrons are also released. Not only that, after this reaction, energy is released and that energy is known as Q value. Clear? So, this is all about fission. And what is the chain reaction? If any one of first fission reaction bombard back to the heavy nuclei, then fission process will continue. That is known as chain reaction. Okay? Then after, let us see a related topic of this, that is multiplication factor. Right? What is multiplication factor? So first of all, this multiplication factor is symbolized as capital K, and it is nothing but it is a ratio of number of neutrons released to the number of neutrons absorbed. Clear? So it is the ratio of number. Why? Because of this reason only, multiplication factor is unitless as well as dimensionless. Right? This K having three value. K is equal to 1. You know that it is known as critical stage of nuclear reactor, in which nuclear reactor works. Okay, then another possibility, K is greater than 1. So if K is greater than 1, then number of neutrons released, energy increases, temperature increases. Such stage is known as supercritical stage, and in supercritical stage that control rods are going inside. This is for your information. Clear? Then last case, that is K value is less than 1. If less than 1, then number of neutrons absorbed they increases, control rules will come out, right? Number of neutrons absorbed increases, it means energy decreases, temperature decreases, and when temperature decreases of nuclear reactor, such stage is known as subcritical stage, right? So this is about multiplication factor, right? Multiplication factor. So many questions are there. Its definition, its unit and dimension, less. If k is equal to 1, k is equal to less than, greater than, right? These are the stages. In this stage only, that nuclear reactor works. Clear? In this condition only, that fission process continue in nuclear reactor. Okay? So, 1, 2, unit, dimension, and that stages. Okay? Then after, let us see few more things. It is of chapter number 13. Now let us take off chapter number 12. Chapter number 12. Sir, chapter number 12 is of atoms. So, before that, one more thing from nucleus, that is radioactivity. So, what is radioactivity? So, radioactivity is nothing but it is a property of radioactive element. So, radioactivity is nothing but it is a property of radioactive elements. Which are the radioactive elements? So, radioactive elements are generally unstable. Which are unstable? Unstable are of two types. That is lighter. Which elements are lighter? Those who have atomic number less than 30. Not atomic number, atomic mass. And heavy means atomic mass more than 170. The lighter element go under fission reaction. Fission reaction? No. It undergoes fusion reaction. Just now we have seen heavy nuclei, for an example uranium-235, right? And they undergoes fission reaction. Got it? So, what is radioactivity? It is a property of radioactive elements. What are the radioactive elements? They emit. What it emits? They emit radiation in all the directions naturally. Which type of radiations are there? Alpha, beta, and gamma. You know that alpha is positively charged, so obviously they come from proton. Beta is negatively charged, means they come from electron. During that lab class, Aryan and a few students has asked me the question, okay, from the nucleus electrons are coming out. There was the statement in our textbook, but you just read that sentence properly. In that sentence, nucleus word is not there. Especially, beta minus is for beta minus coming out from the atoms, not from nucleus. Okay, so mind well this. And gamma, gamma rays are chargeless, so it comes out from that neutrons. Means alpha and gamma emission takes place from nucleus and beta emission from atom. Clear? So, you know that alpha are coming out from that protons, right? Gamma coming out from neutrons, So obviously, number of nuclei decreases as time proceeds. The same definition is there. Dn, number of nuclei disintegrate per unit time is known as decay rate. Clear? So, it is the definition of radioactivity also, decay rate or radioactivity. Decay rate, as number of nuclei decreases, it having minus sign. And this term is known as R. What is R? R is nothing but radioactivity. Clear? So, it is radioactivity, right? It having unit. So, number upon time, time will go up. So, it is second inverse. It having few more units, one Curie and one Becquerel, right? One Becquerel means one disintegration in 1 second. It means one nuclei disintegrate in 1 second, and in Curie, homework. Read from your textbook. Clear? So this is about radioactivity or decay rate. This decay rate depends upon, that is, dN by dt is directly proportional to initial nuclei. Initial nuclei means N0. Proportionality sign, that is dN by dt put equal to, and put a unit lambda, take minus sign here, so it is minus N0. What is this lambda? This lambda is known as decay constant. Clear? So this much informative is okay for radioactivity. Radioactive elements are lighter, heavier undergoes fission reaction, lighter nuclei undergoes fusion reaction, right? Radioactive elements, they emit alpha, beta, gamma. Because of that, number of nuclei disintegrate per unit time. Number of nuclei disintegrate per unit time, that is known as decay rate, and this term is indicated as R. What is R? Is radioactivity. Here, minus sign indicates. What minus sign indicates? Minus sign indicates the number of nuclei decreases. Have a look for a few seconds. Okay? So all these you might have prepared, you might have learned in that regular video as well as the revision video also, right? Today we will have, or you have seen in Zoom also, we will discuss few things in Zoom lecture also. Clear? Let us see about BE. What is BE? That is binding energy. Right? Binding energy is nothing but energy equal to mass defect. Right? Energy equivalent to that mass defect is known as binding energy. Okay? This mass defect is symbolized as delta M. And this delta M you have to put in equation E is equal to delta M C square. And this energy is known as binding energy. That means energy equivalent to that mass defect is known as binding energy. Clear? So, this answer you will get in Joule. But if you want to convert in electron volt, then the answer will be multiplied by 900 31.5. So your answer will be in MEV. This type of numerical, this type of equations we have used in exercise example number 13.3. Right? Exercise example number 13.3. You will have that example in our video. Check it out. Okay, but what is mass defect? So remember that thing, Dhiru bhai, Mukesh bhai, Anil bhai. Okay, so what is mass defect? Is nothing but algebraic sum of mass of proton. How many protons? That is Z. And mass of neutron. How many? That is N. What is N? N is nothing but A minus Z. Okay, so the total mass of proton and total mass of neutrons are more than mass of nucleus, right? So more now, motamati nano minus, right? By this way, you can find the mass defect, and this mass defect having symbol delta M. Put the value of delta M in this equation, you will get the energy, you will get the direct answer of energy in joule. And if you want to convert joule into MeV, then you have to multiply by 931.5. Is it? It's okay. Clear? Good. Then after, there is one more example. Example number 13.10. Right? This type of examples are three. Let us solve any one. Okay? Let us see what is given. 13.10. It is given that half lifetime of SR 3890. So it is given SR 3890. So here atomic mass is 90 and atomic number is 38 and its half lifetime tau half is given 28 years. This 28 years you have to convert into second, and there is a conversion that is 3.154 multiplied by 10 raised to 7 second. I have calculated, its answer is 88.312 multiplied by 10 raised to 7 second. Clear? Okay. Then what is the disintegrate rate? Means rate of disintegration you have to find, and the mass is given, that is M is equal to 15 gram. So this 15 gram milligram is there, sorry. So this 15 milligram you have to convert into gram. So it is 0.015 gram. Clear? Okay. How to solve this? Atomic mass, it is symbolized as M also. Okay. Only these things are given, and you have to find that rate of decay, that is decay rate, and for decay rate we have equation R is equal to lambda multiplied by N, right? That is radioactivity is equal to lambda multiplied by N. Clear? Minus sign we don't have to consider in numericals. Why? Because it indicates only decrease in nucleus. So R is equal to lambda multiplied by N. Here tau half is given. So we have equation tau half is equal to 0.693 divided by lambda. From that, make a subject lambda, you will get 0.693 divided by tau half multiplied by n. What is n? So from that equation, number of moles, mu is equal to n by Na. What is Na? Avogadro number is equal to m by mo. So from that you will have n is equal to m multiplied by Na divided by m. So instead of lambda, from here lambda is equal to 0.693 divided by tau half. It is here multiplied by m multiplied by Na divided by m. Got it? All the values are there. Place and get the answer. Let us say is equal to 0.693 multiplied by m. m बोले तो 0.015 multiplied by Avogadro number. Avogadro number, that is 6.023 multiplied by 10 is to 23. 6.023 multiplied by 10 is to 23 divided by tau half. It is here 88.312 multiplied by 10 is to 7 multiplied by mo. What is mo? That is atomic mass, and atomic mass is the thing by 90, right? Multiplied by 90. Do calculation, find the answer. I am writing directly. That is 7.85 multiplied by 10 is to 8. 7.85 multiplied by 10 is to 8. Is it? Yes. And this rate is in second inverse. If you want to find in Ci, that is Curie, then 7.85 multiplied by 10 is to 8 divided by 3.7 multiplied by 10 is to 10. Right? So this is the conversion. One definition I gave for homework, Curie. What is Curie? If 3.7 multiplied by 10 is to 10, this integration takes place in 1 second, it is said to be a 1 Curie. So second inverse is converted into Ci, that is Curie, and you will get the final answer 2.31 Ci Curie. Mind well, this type of examples are important for exams. Okay, here there will be a change only in that radioactive element. Just follow the steps. These conversions are given will be there in the questions only, so you don't have to remember this. Okay, have a look. Very nice. Let us see what is shunt, what is cyclotron, what is emission, absorption, spectra, right? and Bohr's atomic model, and in Bohr's atomic model its hypothesis as well as its limitations. Okay, I will not write anything, but just you see here. What is shunt? Shunt having low resistance than resistance of galvanometer. It is connected in parallel to convert galvanometer into ammeter. So this shunt, that is resistance of shunt is less than, much more less than resistance of galvanometer, and it is connected in parallel. Why? To convert galvanometer into ammeter. Clear? What is cyclotron? Cyclotron, it is a device to accelerate charged particle, and these highly accelerated charged particles are used in bombardment of any atom. What is emission spectra? What is absorption spectra? That comes in hypothesis number 3. What is first hypothesis? That about stable orbit and stable electron. Second hypothesis is about orbital angular momentum. L is integral multiple of h upon 2 pi. Then after, third hypothesis will give directly to the emission and absorption spectra. When electron transit from high energy level to low energy level, it emits the radiation. At that time, you will get emission spectra, right? What is absorption spectra? If electrons are present at ground state, then electron absorb the energy and will go to the higher energy level. So it absorb. When it absorb energy, you will get the dark lines. That dark lines are known as absorption spectra. So in absorption spectra, you have to think about only this: electron transit from ground to high energy level. Ground to high, because of that it absorb energy and you will get dark lines, right? And for emission spectra, vice versa. So if you will take inverse of this, you will get emission lines or emission spectra. In emission spectra, electron transit from high energy level to low energy level, it emits radiation. And when it emits radiation, you will get dark lines. They are the emission spectra. Limitations of Bohr atomic model. It is 2 mark question for board exam. Right? Which are the limitations? First keyword, odd combination. Rest of the things you have to do. Second, do not give information about intensity of emitted radiation. It gives information about frequency. Limitation number 3. Bohr atomic model is not giving information about electron distributed in that orbits. Fourth is the shape of orbit. Bohr atomic model is failed to give the shape of orbit. It is considered as, at the time, the orbits are circular, but it may be elliptical. Okay? I think this one is enough for today. Rest of the things we will see Till then, goodbye, enjoy, and have a happy reading. And one more thing, give honest text. Thank you very much.